Hello. We are down to the last two assignments in coding. So let's go ahead and get started. This is for grading period 2 for the week of October through October 8th. We will do more than just this one assignment. First of all, thank you for watching the video first and answering the questions. I hope you do well on the questions. So let's look at our assignment. It says I can code a reflection in code.irobot.com, and it's going to make me edit the assignment to look at it. So our essential question is, how do I analyze a picture to find patterns? How do you use loops to code more precisely? How do you use the coordinate plane to help with coding? Because this week I want you to start using this background as you code, because it's going to really help you when you do our final big project, which will start this week also. Um, then it says, what are some shortcuts that can help you achieve your challenge? Hopefully you know those now from past things that we've learned. What is the process that you would use to complete this task? What would you do first? What would you do second? What would you do third? That needs to be up here. And then how can you shorten this task, which hopefully that goes back to here. Actually, that is a repeat question, so I'm just going to take that question off. Okay, so first of all, what is a reflection? And a reflection is a math term. The eighth graders, I believe you're studying these sort of things now, or you have just studied them in math. Seventh and eighth graders, you're going to do all right, because I think these are fun. You've probably done them, but just not known the name, because you look at the coordinates and you flip them. So a reflection is a transformation representing the flip of a figure. The figures may be reflected across a point, a plane. This is called the line of symmetry. So remember, line of symmetry, and this is a transformation representing a flip. So we're going to code the Pac Man ghosts. So looking at them, you can see that if I draw a line down the middle of this one, I can see a line that goes through it. So I know that this is Inky, Clyde, and Pinky. I guess that's Blinky. So if you draw a line and notice the bottom, if I analyze these, what's similar and different about the lines at the bottom? Okay, so you're going to go through, and I would like for you to look at the background, and you're going to use loops. And something I don't want you to struggle, so here's kind of a little tip. Whenever I use a loop the first time, if I'm still drawing or coding, I set it to 1. And even if it gets to, because here's what I hate so much, is if you decide you don't need one or you have to add one, and then you move this all around, and then you get frustrated because you've moved them all around. So kind of a workaround, just put your repeat in and put it in as 1. Also, that helps if you decide you need to move a block of code around, then you have it there. Remember, you can also use comments, which help you tell me that you know what you're doing and you're not doing it with just random abandonment, which is you're going to need to know about next. But if I code it first, I'm going to go ahead and run my code. I'm set up on Rabbit. It's going to go. The first thing that I did was I used this to move the robot back to where I want it to be, kind of at the bottom. Remember, these boxes are 16 by 16. So whenever he starts, he's right smack dab in the middle. So that would mean that he's pretty much 8 by 8 by 8 by 8. So if I want to move him to a line so that I can start using these grids to help with my coding, I probably want to move it 8 in some direction. That's why I chose 40, because I did 16, and 16 is 32 plus 8 would be 40. And that's how I came up with 40. So you're going to code the Pac Man robots, and or Pac Man ghosts, and put them on the graph paper. Another thing I'd like for you to look at for this week is our rubric. I'm going to start adding these to all of our assignments. I may add them to some of our past ones, but this goes with my student growth goal. I don't know if anybody else in class talks about theirs, or in your classes talks about those. So if I can code a reflection in iRobot.com, and it says one of the things that I have is that I can get the assignment completed on time and follow all of the directions, because a lot of you are either A, not trying things, or B, turning in things late. When you don't try and turn things in late, in order for me to be able to assess you, I have to give you more tasks to do. So you're creating more work for you, which creates more work for me, which then we all start going, man, I hate this stuff. So if you would just do what we do when we give it to you the first time, life would go much better. So notice that if you're coming up green, there's a coding color that we used to use when we were back down in 128. I don't know if the sixth grader or eighth graders remember this, but I had it on the wall and I had green. If you were right on, you were heading on it, everybody's hitting the numbers, everybody knows what they're doing, you would be green. Yellow means you're doing really well. It's kind of like a stoplight, but we also have an orange. And orange is for the people that are starting to improve. Red means we're all just sitting there struggling or we're not doing it and we're incomplete. So the goal is that I need to get most of you to be up here in the green mastery section. This last grading period, most of you, well, I shouldn't say that. A lot of you, and I'm going to go back and analyze it, that a lot of you kind of were here. Either you're not doing it and I'm having to give you gobs, I'm having to use the shotgun effect, that I'm having to give you gobs of assignments in hopes that some of you do something. It just makes more work and makes us all tired. So here I've got evidence of math being used rather than by trial and error. So if I can tell from where your robot is going and looking at your code, and you can also use those comments, that you're just not picking a number, I think I'll use 7, that you will actually use math, knowing that it's 16 by 16 is the size of the box. 16 by 16. The whole thing is 150 by 150. So, and you can calculate that if you add those up. So anyway, so can I tell that if you are showing evidence that you're using math when you calculate these? Remember when I talk about angles and I'm like, if you divide this is a 90-degree angle, half of a 90-degree angle would be a 45-degree angle, half of a 180 is a line. If you start using those things, this really has a lot of connections to math. The problem with connecting to science is that we have friction on the board and we need to make things smaller. But anyway, it's evidence that math is being used. Applying coding tasks such as loops and variables in your coding. So notice that if you just throw some variables in there, then I'm going to say that you attempted to use a variable. But if it doesn't do anything, somebody did coding last week and it just said variable, and they have their variable equals 1. Then they have variable equals 0, but they never used it. They just put a whole bunch of them in there. And then finally, if you're coding efficiently. So if you're getting, sometimes I will look at your code, and we are, before our final project, you're going to have to do a task where you read code again, kind of like that code break thing. And if I just see lines where you're just wandering around or you just kind of doodled around, then that means that you're starting to get the idea, but you're still just pretty much pecking along and doing random things. My hope is that everybody gets here to green, which is mastery. Green is my favorite color for a reason. And then we can move on to the next task. So we have this task, coding the ghost, should be very simple, hopefully fun. And then we have our next big task, which you're going to have to all collaborate together. So for your backpack, that would make you a productive collaborator. This one, your backpack piece is, I want to close this, is that you are emerging innovator. You could also, if somebody wants extra credit, extra practice, wants to dazzle us with your talent, and some of you can code one of your math reflections for me. Give me evidence that you had it in math. I don't know, 7th and 8th graders if you do, 6th and 7th graders if you do any of that. But 8th graders, I know if you want to code one of those, we would love to have it. Then your other thing is that you've got math terms in here. You've got reflection and line of symmetry are your two math terms. Reflection, I gave you the definition of, ta-da, and I'll even read it again because this is a video. A reflection, once again, is a transformation representing a flip of a figure. And so you're going to look and see how this side flips to that side, because that's all he is a flip. Okay? All right. Any questions, please let me know. And I hope we have a great week.